green laser.
Oh yeah, wait a minute. Does this work for the back and forth? Yeah.
There we go.
Because then it might stop me accidentally bashing the computer and doing
right.
something insane. Okay, we are ready to get started shortly. Well, right now. So I would like to begin by acknowledging that the land on which we gather is the unceded traditional territories of the Coast Salish peoples, including the territories of the Musqueam, Squamish and Tsleil-Waututh nations. And second of all, to welcome you here to the Vancouver Aquarium, an ocean-wise initiative. For those of you who don't know too much about Oceanwise, our mission here at Oceanwise is to inspire both the local and global communities to become oceanwise. We strive to increase understanding, wonder, and appreciation of our oceans, empowering us all to help protect our ocean health and the planet as a whole. And I like to put a little video that our content team come up with that are always very inspiring. So here's a little video about why it's so important to protect our oceans. So I also want to tell you about a few upcoming events. So right now, none of these, the registration for these events aren't yet open, but I just want to give you a bit of a flavour of some of the things that I have in the works and encourage you to go to education.ocean.org/ocean matters. And if you scroll down, you can subscribe for updates and you'll be notified when the registration for new events opens up. So the August lecture on Tuesday the 28th, we haven't yet confirmed exactly who will be giving the talk, but it'll be likely an Oceanwise researcher who will talk about some of the work that we're doing here at Oceanwise, investigating plastic pollutions and possible solutions to some of the problems. In September, I'm very excited to have Dr. Love S.A. Shelley, who's actually in the audience. She's come along. She recently graduated with a PhD from UBC, and she's very passionate about investigating sustainable technologies, as she's a chemical engineer. And so she will talk about some of the work that she's doing looking at creating biodegradable and bioderived plastics. So that's extremely exciting. And then somebody in one of the feedback forms suggested that it would be interesting to have a talk about sea star wasting disease. So I found somebody in Chris Harley's lab, a postdoctoral researcher, who will come in and tell us all about sea star wasting disease here in the BC coast. So that's all going to be pretty awesome talks coming up. And then, also, yes, to remind you, so yeah, thank you all for coming. It's fantastic to have everybody here, and I'm really pleased that we're able to offer these talks for free, so we can make them as accessible as possible to as many people as possible. But obviously, these events are not free for us to put on. So if you happen to have $1 or $2 in your pocket, there's a donation bin just outside, and anything that you can spare will allow us to carry on putting on programs like this. So thanks very much. And now I will introduce our speaker for tonight, Eric Balke. So he is the coordinator of the South Coast Conservation Land Management Programme, and he manages a portfolio of conservation lands as part of a partnership, including organisations such as the BC Ministry of Forests, Lands, National Resource Operations, Rural Development, Ducks Unlimited Canada, the Nature Trust of British Columbia, as well as the Canadian Wildlife Service, Environment and Climate Change Canada. He's completed his BSc in biology at UBC, and he's recently graduated from BCIT SFU with an MSc in ecological restoration. So I'd like to welcome Eric to give his talk.
There we go. All righty. Can everybody hear me? I'm on the speakers. Yeah, we're good. Well, first off, thank you so much, Ruth, for inviting me to give this presentation, and thanks so much to the Vancouver Aquarium for hosting us. It really is an honor to be here, I have to admit. So first off, I have a question for the audience. So please put up your hand if you are a volunteer with the Vancouver Aquarium. All right, so we've got a handful there. Well, during my undergraduate degree, I was also a volunteer here at the aquarium. I was a gallery educator and gallery presenter volunteer. So it was my job to engage the public in a dialogue about conservation issues and the animals of the aquarium and try to enable them to connect more with those topics. And I have to admit, after talking with members of the public on countless days in all weather conditions, without those experiences, I definitely probably would not be doing this lecture in front of everybody here today. So I have lots of fond memories as a volunteer here, definitely. And so for a bit of my background, as Ruth mentioned, I studied biology at the University of British Columbia. And then after that, I've been involved in aquatic ecology research. I actually also came back to the aquarium to do a couple marine mammal training internships. Tons of fun. I did some public health research. I also studied orangutans for a while. And then most recently, I dove into the Fraser River Estuary as part of my Master's of Science studying ecological restoration. And so that's how I got onto this topic. And so I'm really excited to be able to share this with everybody today, because I think it's not only a really fascinating topic, but also a really important one. And so for today, I kind of have organized the theme of this presentation around the Fraser River Estuary and how it is ecologically important, and it also protects our communities from coastal flooding. However, sea level rise, this threatens these ecosystems. And so today, I'm not going to be going in enormous depth into a lot of the topics. I'm just going to try to give a bit of an overview for each one, but we'll be talking about the Fraser River, the formation of the Fraser Delta, and how we've modified the area. We'll talk about the ecology of the estuary, including major threats to the estuary. I'll give some examples of what's being done to protect and benefit the estuary, and then we'll talk about the threat posed by sea level rise. So, first things first, that program I'm a part of that Ruth mentioned, the South Coast Conservation Land Management Program. So this is a partnership between the federal government, the provincial government, Ducks Unlimited Canada, and the Nature Trust of British Columbia. And so the purpose is to work together to use a collaborative approach to better manage and look after provincially designated conservation lands throughout the BC South Coast. So I am the land manager for a bunch of conservation lands in this part of the province. And for this presentation, I'm sharing my personal perspectives of the estuary, so my view does not necessarily represent those of the partners of my program. But first, before we talk about the Fraser Estuary, we have to talk about the Fraser River. So, the Fraser River, believe it or not, it is actually the largest river meeting the west coast of Canada. It's about 1,400 kilometers long, and it drains a watershed of over 233,000 square kilometers. So that's about 1/4 of the entire province of British Columbia, and that's about the same size of land as the countries of Romania or Laos. And so the Fraser River, it actually has what we call a snowmelt-driven discharge, which results in this late May to early June freshet. So what that means is that during the winter, you have the snowpack building up throughout the majority of the watershed, and then as the snow melts, that creates a large discharge of water throughout the Fraser. So with the black line here, you get a sense of once it hits that freshet period of May, June, the Fraser River's flow just it jumps up almost astronomically relative to the baseline in the middle of the winter there, and then it will slowly taper off. And so flows of the Fraser River range from 1,500 cubic meters per second to 17,000 cubic meters per second, and it carries an average sediment load of 20 million tons of sediment down the Fraser River out into the ocean. I mean, these numbers are kind of incomprehensible. So I was trying to wrap my head around 20 million tons. And so the mass of one African bush male elephant is 6,000 kilograms. So that 20 million tons of sediment is equivalent to about 3.3 million bull elephants in mass. So it's a lot of elephants of sediment, just going to say that. And so here we have a diagram which describes the formation of the delta over the last about 13 to 10,000 years. And you can see that all of those 3 million elephants came out into the ocean and have formed the delta that we are familiar with today. And so in this figure, of course, the yellow sediments are those deltaic sediments, those riverine sediments that have been deposited over time. And so similarly, this figure illustrates that for the Fraser Valley, those yellow sediments being the delta sediments. And so it's not just at the delta where those sediments have been deposited, but all throughout the valley. And so looking at the Fraser River here, there is tidal influence from the ocean all the way past Mission to the confluence of the Sumas and Fraser Rivers. So you still see those tidal fluctuations in water level. And then even Pitt Lake, that's a tidal lake. So the influence of the ocean goes up fairly far. However, the salt influence ends at about the Port Mann Bridge. And so we say that the salt wedge, that's the furthest extent of it. And so what we have with the Fraser River is freshwater with sediments is actually lighter than salt water. So you have the freshwater which flows over top of the salt water that comes in from the ocean, and you get a very distinct separation between them. And so you get an understanding of that salt wedge. And so when the Fraser River's flow is lowest, that salt wedge can progress all the way up to the Port Mann there. And so that's quite often considered to be the limit of the estuary, where you have that saltwater influence. And so this is a figure describing the types of land cover in the lower Fraser Basin prior to 1827. So in the black, we have forests, while this gray shaded area, those are wetlands. And so you see how that corresponds quite well with those deltaic sediments. And so the ecosystem here, historically, it used to be this gradual transition going from the ocean where you had eelgrass into mudflats, into tidal marshes, into grasslands and shrubs and cottonwood forests throughout the delta here. So it was this very beautifully, gradually transitioned set of ecosystems. And in fact, Lulu Island, so that's Richmond, and Delta, these were once large deltaic marshes that were flooded for almost half of the year. And then you have the emerging uplands arising through the formation of different features, and then of course the tall grass covering a lot of the rest of the area. But of course, prior to 1827, we had First Nations people who have been in the Lower Fraser Basin since time immemorial. So the Halkomelem-speaking people, the Stolo, they established villages and towns throughout the Fraser Valley and the Fraser Delta. And I've heard of oral stories from First Nations being present in the Delta as it expanded into its current location. And the Stolo people, well, they used the Fraser River as a busy artery for transportation and trade of dried fish, dried bulbs and roots, and shellfish and canoes. But the major feature of the local economy of the Stolo was the salmon and the salmon run. As well, other fishes like sturgeon and ulukan were very, very important for them. But the salmon runs, they attracted First Nations of several different languages to the Fraser River. So you have First Nations from the San Juan Islands, from the Gulf Islands, from southern Vancouver Island, all coming here to participate in those the salmon runs. And so European colonization, it started with the first colony in Fort Langley in 1827. And then in the late 1850s, the first settlers appeared in the Fraser Delta area and the land along the rivers and sloughs, giving them convenient access to the waterways there. And so here we have a map of the Fraser Valley. And since colonization began in 1827, we have drastically modified the Fraser Valley. And so looking here, well, that yellow star, that's us right there at the Vancouver Aquarium. You see all of the roads and all of these lines on the map that we've drawn. And even it's visible from a satellite image. And you can see that the floodplain, oh, well, that's the next image, isn't it? So first off, we have the Fraser River. You get a sense of exactly where it flows there. And then this is the Fraser River floodplain. So that's the area that would be flooded with the waters of freshet in May and June. And this floodplain was filled with these very fine and rich deltaic sediments. And they were also wetlands of different types. But of course, since then, we've converted it into farmland and other industrial, agricultural, and urban uses. But realize living on an active floodplain leaves us quite vulnerable. So I'm going to show you a Google Earth image from this direction. So you get a look at Sumas Mountain and the Fraser River there. And then I'm going to show you an image here of 1948 when we had this gigantic flood from the Fraser River. And so here we have the Fraser River, followed by the yellow line here is the Vedder Canal. The dark blue line there is Newcomen Slough. And then, of course, we have Sumas Mountain here and here. And you really get a sense. In this picture, this is today, all of this land is dry. But in the 1948 flood, all of that area was flooded. And so was much of the lower Fraser Valley and the Fraser Delta. And so, I mean, like I said, that's the consequences of living in an active floodplain. But flooding in 1894 and 1948, that spurred on dike construction to help protect our communities. So that's what these red lines are. It's pretty much all of the dikes that we've constructed to keep the river away from our communities, to keep our communities safe. However, when you construct dikes like that, you actually disconnect the Fraser River from its floodplain. So if you can imagine, every single year, the river depositing fresh water and sediments onto the low-lying areas. And then all of a sudden, you create walls blocking that delivery of sediment and water. That can have significant ecological repercussions. And of course, that has significantly altered the ecosystems and all of those wetlands that used to be there. And so this figure is actually from a publication that was quantifying how much wetlands we've lost since 1827. And it's estimated that wetlands used to cover about 10% of the lower Fraser Basin, but now they only encompass about 1%. So this estimate says that we've lost 90% of the wetlands that used to be throughout the lower Fraser Basin. But now we're going to be focusing in on the Fraser Estuary, so the delta here. And so this is the area that I'm most interested in, and I've spent a lot of time in myself, I have to admit. So, what is an estuary? Well, first off, an estuary is a partially enclosed body of water and its surrounding coastal habitats where salt water from the ocean mixes with fresh water from rivers or streams. And so estuaries, they trap nutrients and sediments that is carried from the land by rivers and from the ocean by tides. And so it's this big mixing place of salt and fresh water. And so this means that estuaries are home to only certain types of plants, those that can flourish in the physical conditions that are unique to estuaries because of that salt and fresh water. So when you mix salt and fresh water, that becomes brackish water. And so for the delta here, we have here the north and middle arms of the Fraser River, through which about 12% of the Fraser's flow goes. And then through the main arm and Canoe Pass, about 88% of the water the Fraser travels, but nearly 100% of the sediments are traveled through those areas. And so the delta front, it currently contains a range of tidal environments, including mudflats, eelgrass meadows, and tidal marshes. So we're going to start to look at the mudflats of the estuary here. And so believe me, it's not just mud. So it might look fairly empty, but mudflats are host to a multitude of marine invertebrates that support migratory birds and other species. That includes something called biofilm, which is this dense mucus-like layer that forms on the surface of the mud. So you can see here a western sandpiper slurping up the biofilm there. And so this biofilm is created by bacteria and diatoms that settle out of seawater and secrete mucus that binds them to the mud so that they don't wash away with the tide. And this is a very high energy food for species like the western sandpiper. And it's really important for them to fuel up when they come by the estuary for their long migration routes. And so here, I actually have a video I took a couple of years ago just outside of the Westham Island Marsh, and it gives you a sense of kind of the scale of the mudflats. And so it almost looks like you can walk out there forever. It's just beautifully flat, and you can actually probably walk out for at least 5 kilometers before it gets a little too deep, at least at low tide. Because remember, this is an intertidal environment, so during high tide, my head might almost be covered here. It's beautiful out there. It's one of my favorite places around, I have to admit. Not biased, definitely not. So next, with these blue polygons here, we have eelgrass meadows. So these are subtidal and tidal. So subtidal means that they are never exposed to the air and they're always underneath the water. And if they're tidal eelgrass meadows, then that means sometimes they're submerged and sometimes they're exposed to the air. And so these eelgrass meadows are home to a wide range of marine invertebrates, and they're also a nursery ground for many species of fishes. Also, eelgrass meadows play a very important role in carbon sequestration. So the green polygon here, well, these are the tidal marshes. So these are the places in the estuary that I have spent the most time and had the most fun, have to admit. So tidal marshes along the delta front, well, they actually attenuate wave energy. So they slow down the waves from the ocean that are reaching our shoreline. So they actually act to protect our communities. Also, the tide marshes and marsh channels, these are important for many species of fishes, including millions of out-migrating Pacific salmon. And so here's an example of the marsh off the west coast of Richmond. So this marsh, I'd ballpark that at about ½ a kilometer wide. And then this is an example of one of the channels that goes through. And of course, this is in an intertidal environment. So the water would be possibly above the top of those vegetations at high tide. So the fish definitely will be using that channel and feeding a lot of the invertebrates that come from the marsh. So these tidal marshes, they also sequester large amounts of carbon, and the rhizomes and seeds of the marsh plants are food for shorebirds and migratory birds. So here we have an example of an estuary food chain. And so these tidal marshes, they actually kickstart something called the detrital food web. So you have marsh plants, which create surfaces for protozoa, which are then eaten by little invertebrates like amphipods, which are in turn eaten by little fishes, which are in turn eaten by, well, not so little birds, such as the great blue heron there. And so this is a figure describing the annual plant production in different types of ecosystems. So believe it or not, estuaries are actually among the most productive ecosystems in the world. So that means that they produce the greatest biomass, or the largest amount of leaves and stems and roots compared to other ecosystems on average. And so it's even more than the most intensive of agriculture. And so you can understand with such a productive ecosystem the role that it may play in carbon sequestration. And so the Fraser Estuary, well, it's the last major stop along the Pacific flyby migratory route up to the Arctic for a lot of migratory birds. And as such, it's actually one of the most important areas for wintering and migratory birds in all of Canada. And so the estuary is actually designated as an important bird and biodiversity area. It is also a site of hemispheric significance as designated by the Western Hemisphere Shorebird Reserve Network. So try to wrap your head around that. Hemispheric significance. That means it's relevant to migratory birds for half of the world. And also, it is designated as a wetland of international importance under the Ramsar Convention. So you get the picture here. It's really ecologically important. And so the Fraser Estuary here, well, it's actually, it also contains 5 provincially designated wildlife management areas. So the purpose of a wildlife management area, or WMA, is to conserve and manage critical habitat for the benefit of regionally, nationally, or internationally significant fish and wildlife species. And so the WMAs include the Sturgeon Bank, Roberts Bank, South Arm Marshes, Boundary Bay, and Serpentine wildlife management areas. And so these are some of the areas that I'm involved in the management of them from a conservation lands perspective. And so at in the estuary here, as I mentioned, we've heavily modified the delta. So as we discussed earlier, the majority of the lower Fraser is diked to prevent flooding. And so you have that disconnect of the river from its floodplain. Also, as you can see from all of those other lines on the map, we have houses there, urbanization. We have farms there, agriculture. We also have lots of industry there. This is important for our communities, for our economy, and not just for ecosystems. And so for examples of industry, we have things like the airport up there on Sea Island. We also have Delta Port down here in Delta. And so that's it's a super port. It's a crucial corridor for receiving and transferring goods between continents. And in order to accommodate a lot of industry, there's a lot of, we'll call it maintenance, that's done to the Fraser River. So for example, there's maintenance dredging which goes on. So historically, before we modified the estuary, the main arm of the Fraser here, it used to only be about 2 meters deep. But in order to accommodate large vessels and to prevent that accumulation of sediments, we now dredge it to a depth of about 12 meters depth. And additionally, the river is trained by several structures. So we call these training dikes or training jetties. And so you can see here examples of them in the red line. However, the biggest one of them all is called the Steveston North Jetty. It's this one right here, which trains the main arm of the Fraser River. And its construction was completed in 1932. And so prior to the construction of this jetty, which this jetty, it might not look like it, but that's 9 kilometers long. It's an incredible structure. And it ensures that the river stays put so that we can have different ships travel up the main arm of the Fraser. But prior to that, as you can see from this figure here, with these different lines, the main arm of the Fraser used to kind of flop all over the delta front. It's like in front of a used car lot, you know, those wind people, I don't know, what does anybody know what those are called? Yeah, I don't know either, but that's kind of the metaphor, the windsock, yeah. That's the metaphor that I think of for the main arm of the Fraser River prior to the Steveston North Jetty, just flopping all over the place there. And it actually took them 20 years to construct this jetty. So it was definitely done in stages, cost a lot of money, and took a lot of time. But we still rely upon it today to maintain the Fraser River for industry and navigation. So now let's start talking about threats to the estuary. So looking again at the tidal marshes here, I just wanted to talk briefly about the Lulu Island foreshore marsh here. So this is actually something that I studied with my master's research as part of something called the Sturgeon Bank Marsh Recession Project. And so zooming in on this marsh here, on the left side, we have an orthophoto, so looking right above the marsh. And on the right side, we have a photo taken from an airplane. And so you get a sense of approximately present day, the size of this intertidal brackish marsh. And the red lines in each one, well, they match up. They're actually connecting the dots between a few navigation towers there. But the next image I'm going to show you is also an image taken from an airplane, but taken in 1979. 1970, yeah, getting this the right century there. Oh dear. Except this second photo will be taken from an opposite direction. So I'll try to help orient you here. So the red lines match up, but the image on the left is facing south, while the image on the right is facing north. The green stars match up, but you can see that the marshes, they do not match up. So between those two dates, as you can see here, indicated by the yellow line, that is the approximate location of the present-day marsh leading edge. So this marsh off the west coast of Richmond, we have lost a lot of it. In fact, we have lost at least 160 hectares of this marsh, and we don't know why. Further to that, from 1989 to 2011, I know of no human being that realized that we were losing this marsh. It was just slowly disappearing over time. It's kind of this concept of shifting baselines, where every new generation, or perhaps every few years, you have a new baseline of what is normal. And if something changes gradually over time, sometimes you don't have that memory of what used to be normal or what used to be natural. And then all of a sudden you establish a new baseline, a shifted baseline, perhaps of a degraded state, as we have here. And so although we've lost this much marsh, it actually does not look like sea level rise is the cause of this marsh recession. And so this diagram is meant to be confusing. It doesn't matter about following it. I'm using it to illustrate how everything is connected. An estuary is a very dynamic environment. And so there are many possible factors that could be contributing to marsh recession, and many of them are interconnected. And so it really is difficult to conceptualize how they're related, let alone to parse out a single recession mechanism to test it with scientific experiments. And so for the Sturgeon Bank Marsh Recession Project, to date, we've been able to get a much better understanding of how and when the marsh receded, and we've started to narrow in a bit more on some likely hypotheses or likely ideas to explain why the marsh receded. However, quite frankly, it does not appear there's a smoking gun. It does not appear that there's one reason that is highly likely to have caused the Marsh recession, and we suspect that it's most likely that several factors have contributed to this recession. But quite frankly, I could spend an entire lecture series on this topic, so we're going to park it for now. If you have questions about this, I love talking about it. Marsh recession, it's one of my favorite topics, so we can chat later. But moving on. Unfortunately, it's not that one foreshore marsh which has receded. Based on the work of the Marsh Recession Project, it's actually all 4 of the major brackish marshes of the Delta Front have receded to different extents and in different patterns. And again, we don't know why the marsh is receding. However, there's other ways in which we've been losing our tidal marshes as well. So under the Federal Fisheries Act, if a proponent, if a developer, if industry destroys fish habitat, then they must compensate for that loss. So most often that means that they must create or restore a similar ecosystem nearby. And so in the Fraser Estuary, as you can see from a bunch of these red dots and lines, from 1983 to 2011, there were quite a few of these compensation projects as required under the Fisheries Act. However, in 2015, there was a review of a sample of these sites, of about 54 of these sites, to evaluate did these compensation projects accomplish the goal at the time. So the goal at the time was a no net loss policy. So were they able to offset the ecosystems, the habitat, the fish habitat that was destroyed? However, this report that found that only 1/3 of the sites surveyed achieved that no net loss target as required by the federal government. So that means that 2/3 of these marsh compensation sites failed. So quite frankly, when it comes to restoring and enhancing fish habitat in the Fraser Estuary, we're not very good at it. We're not very successful. So for other development, down back at the Superport there, we have Deltaport. And so right now, the Vancouver Fraser Port Authority is undergoing an environmental assessment for expanding this port facility. So I'm going to flash this red polygon here, and you get a sense right there of the proposed expansion. Here, I'll give it again. There we go. And so, I mean, this thing, it's actually quite a large construction. It's about 1.3 kilometers long, I think. And the creation of it would destroy a lot of subtidal ecosystems, including subtidal eelgrass. And so the port, so as I mentioned, this is undergoing a federal environmental assessment process, which will review the proposal, better understand the possible economic, social, and ecological effects of the proposed development, and then the federal government will make the call as to whether or not to go ahead with the project. But because the port knows that this project would destroy a lot of fish habitat, they're actually trying to proactively create and restore tidal ecosystems in advance of the Roberts Bank Terminal 2 being approved. And actually, before I go to that, I want to touch on one quick thing. Sorry, got my slides mixed up. So regarding that biofilm on the mudflats that I mentioned, there was actually a written response from Environment and Climate Change Canada to the Canadian Environmental Assessment Agency. So the agency responsible for that environmental assessment of this Roberts Bank Terminal 2 development. And Environment and Climate Change Canada describes the predicted impact of this project on hundreds of thousands of sandpipers as potentially high in magnitude, permanent, irreversible, and continuous. So there are some significant concerns regarding this Superport expansion. But like I mentioned, the port understands that if this project were to go ahead, they would have to compensate for that loss of fish habitat. So they've been trying to proactively create and restore tidal ecosystems, create and restore fish habitat throughout the estuary. And so they've also been trying to learn from a lot of those failed projects that I talked about previously. So one of the downsides of the projects that happened over the last few decades is that they were done in almost these tiny little postage stamps a lot of the time. So really small sites just scattered here and there. And so one of the recommendations from that report is maybe try creating much bigger sites that have a greater likelihood of succeeding because you have a smaller perimeter to volume ratio. That's a long story short there. However, there are some concerns that there isn't exactly a lot of space in the Fraser Estuary for such large-scale compensation projects. Additionally, for years, there's always thoughts of expanding the airport. So there's been several proposals, from what I understand over the year, of possibly creating a third runway throughout the tide flats. But perhaps an issue which is more familiar to us these days is the Massey Tunnel down here connecting Delta and Richmond. I talked too fast. I recognize that. Yeah. We're good. So here we have the Massey Tunnel. This is what it looks like today under the water. But the previous federal Liberal government had a proposal to create a bridge going over top. One of the concerns, if this were to go ahead, is right now the Massey Tunnel is one of the spots that's limiting how low we can dredge the river. So, like I said, right now we dredge it to about 12 meters depth, although historically it was only about 2 meters depth, the main arm of the Fraser there. So there's some concern that if the tunnel was to be replaced with a bridge, then there would be a push to dredge the river to even greater depths, to allow larger ships upstream to the ports and the LNG facilities there. And then there could be different ecological repercussions with modifying the salt wedge. Also, some farmers have concerns about when they pump up fresh water from the river, they don't want to be pumping up salt water. So another threat to the estuary, invasive species. So there's this one really nasty invasive species called English cordgrass, or Spartina anglica. I'll refer to it as Spartina. And so this is a species of grass, originally from the UK, and it is a highly effective colonizer of mudflats and tidal marshes. And once it gets established, oh boy, it is really hard to eradicate, and it can take over. And what it does is it creates these monotypic stands. So in this stand, it's the only plant that grows and that affects local biodiversity and really alters the ecology, where you don't have those plants necessarily that the shorebirds can eat or that are part of that detrital food web. And so there's some big concerns that if this plant continues to spread and change these tidal marshes, although there may still be vegetation there, we may, in effect, be losing those ecosystems that all the fish and wildlife rely upon. And so there's actually this really concerted effort to try to eradicate this invasive species. So this is just some of the mapping from 2015. So you can see that Spartina anglica is found throughout the perimeter of Boundary Bay and the Roberts Bank foreshore here. And so it actually came up from Washington State originally, and folks in the States have been also doing a very persistent eradication effort. So it's this kind of transboundary effort to eradicate this invasive species. So other threats to the estuary include overabundant species. So these are snow geese. So these snow geese, they actually breed up in Siberia. They migrate down to the Fraser and Skagit estuaries for October through March. And they eat all sorts of marsh plants, so the roots and rhizomes of certain plants in the low marsh. They'll also go into farmers' fields and grass fields. You'll see them in quite large flocks. If you ever go to Westham Island from October to March, you're quite likely to see one of these large swarms of geese. And although these geese, it's not like they're invasive. They've been here for I don't know how many millennia. However, over the last 3 decades, their population has increased 2 to 3-fold. And so there's a concern that they may actually be contributing to marsh recession, because with these increased numbers, there's that increased herbivory. The geese, since there's more geese to eat out the marsh, perhaps. Also, there's another species of goose to be concerned about from an estuary perspective. So Canada geese. Historically, any Canada geese that would have been here would have been a migratory subspecies. However, throughout the 1900s, the provincial government, the federal government, and several NGOs introduced 3 subspecies of Canada geese from other parts of Canada to the estuary to supplement the local hunting population. However, hunting has kind of decreased in popularity over the last few decades, and these 3 non-native subspecies of Canada geese have interbred and formed a hybrid race that no longer migrates and actually resides year-round in the lower Fraser Valley. And so these geese also eat the marsh, and you've seen them in fields and agricultural fields as well. But for Canada geese, we really have insufficient data to accurately estimate their current population size, and thus to really understand the scope of their effect on the estuary. So these 2 pictures are examples of the effects that geese can have on marsh. So this one on the left here, this is low marsh off at Brunswick Point, off the west coast of Delta. This is in the summer, and you can see these pits here where Canada geese have kind of stuck their bills or their beaks in the sediment, moved it around, and grubbed out for the roots, for the rhizomes of that sedge there. And then here, this is a picture taken in October where a grad student has an exclosure up here trying to keep geese out of a certain area, but all of this area around it was vegetated before. So you can see this red polygon here. That's kind of how much of the marsh was eaten out in that one area when snow geese decided to pop on by. Fortunately, the goose exclosure for our experiment is somewhat working, so I count that as successful. But that just illustrates kind of the potential repercussions when you have too many of these geese. So when these geese are overabundant, they can really eat out the estuary potentially. So the natural question next is, what are we doing to protect and conserve the estuary? So, as I mentioned, there's my program, which is this big collaboration between a bunch of different parties to try to do a better job looking after conservation lands. So sometimes maybe it doesn't look like anything's going on, but I can assure you different folks are trying to come together on the same page and do some good for the estuary. Another example is through the Federal Ocean Protections Plan, the Coastal Restoration Fund. It's actually a $75 million fund over 5 years to fund different projects throughout Canada. And actually, there are 2 projects from this Coastal Restoration Fund that have been funded in the Fraser River Estuary. And so, looking at the estuary again, we have a project led by Raincoast Conservation. And so they're looking at some of those river training infrastructure, so such as that jetty, the Steveston North Jetty. And they actually want to punch a few holes in there to not only increase fish passage through it, because these river training structures also prevent fish from accessing certain areas, so going from the main arm of the Fraser into those marshes that we still have. But also by creating these holes, it's possible that you'll be increasing freshwater and sediments that are delivered to the foreshore marshes, which again are directed out by the jetties into the Strait of Georgia. There's also a project being led by Ducks Unlimited Canada that's also going to be increasing fish passage to different tidal channels and tidal marshes. They're also looking at restoring some marshes that may have been affected by invasive species, such as there's an invasive species of cattail, believe it or not. And they're also considering restoring an old agricultural field into a tidal marsh. And then, quite frankly, there's a ton of additional research projects going on in the estuary. So I'm going to give a very brief overview of these. But I just want to illustrate that there is attention being given to certain topics, maybe not as much attention from a research perspective as there was in previous decades, but there are folks that are trying to learn more and better understand these ecosystems. So UBC with Rain Coast Conservation and Ducks Unlimited, they're looking at how fish, specifically different species of Pacific salmon, use these estuaries and the timing of it throughout the summer. There's also a grad student through BCIT and SFU who's doing a bunch of vegetation surveys of a bunch of the foreshore tidal marshes, trying to better understand how the marsh communities have changed over time. So it's getting to that idea of shifting baselines where if we look at the marshes now and count that as pristine, well, that's not really taking into account what the marshes used to be. So this project is helping us to understand maybe how the marsh plant composition has changed over the last, say, 3 decades or so. There's also a couple of grad students at UBC studying eelgrass ecology in a couple of locations. We also have folks from Simon Fraser University looking at the energetics of western sandpipers. There's another grad student who's modeling the possible effects of an oil spill were it to happen on the Lulu Island foreshore. And then as part of the environmental assessment process, the port is doing some research on biofilm. And then kind of further to that, there used to be this program in the Fraser Estuary. It was called the Fraser River Estuary Management Program. And so this was a partnership between federal, provincial, and regional government agencies to foster coordinated and sustainable activities in the Fraser Estuary. And so this is this was a program that a lot of folks really liked the idea of, but unfortunately the federal conservatives closed this program in 2013. However, the current federal Liberal government announced their intention to restart this program because all levels of government locally and the port and NGOs and First Nations, they were all on board. They all said, you know what, this was a good program, let's bring it back, but let's bring it back even better. And so right now, the federal government, from what I understand, is hoping to bring it back perhaps by the end of this calendar year. So we'll see, but hopefully that will be good for the estuary. Additionally, there's a recent effort to restart something called the Shared Waters Alliance. So that's actually an international working group that's focused on water quality of the shared Canadian-US waters of Boundary Bay. So trying to, again, not let borders get in the way of responsible conservation. But now moving on to a topic that I've learned a lot about over the last 2 years, and it still continues to surprise me, sea level rise. So the first question becomes, what is sea level rise? So this is an increase in the global mean sea level as a result of an increase in volume of water in the world's oceans. So pretty much with global climate change, if you are heating up the water, because of water, its unique chemical properties, when you heat it up, it expands. And so, I mean, you can think of a small amount of water, if that expands, it's not really going to expand into that much larger. But when you have the entire ocean warming up, the volume of the ocean increases, and thus you have seas rising. Additionally, with global climate change, you have the ice sheets melting, and that's also adding more water to raise the levels of the ocean. And so for these ecosystems of the Fraser Estuary, for these conservation lands, quite frankly, the whole estuary is at risk from sea level rise. And so, as we mentioned before, when we have the Fraser River going through here, this whole area here, so that's pretty much all of Richmond, most of Delta, and a quarter of Surrey, well, that's those deltaic sediments. So they are either at or below sea level, most of it. And so these areas are at risk of flooding with sea level rise, because with predictions of up to 1 meter of sea level rise by the year 2100, the delta is at risk of flooding because the current diking infrastructure is actually insufficient to protect our communities. So to better understand how these ecosystems, these tidal ecosystems will respond to sea level rise, I have these fancy PowerPoint slides here. So under a normal scenario, if we did not build dikes, with coastal marshes, if you raise the sea level, the thought is, well, the marshes will just migrate landward because there's still space for them. And you get kind of that transition zone of the ecosystem, and the transition kind of continues upland. However, if you put a dike there with sea level rise, unfortunately, there's no place for these tidal ecosystems to retreat landward. And so you actually, it's anticipated that you see a loss in these ecosystems because they are drowned out by the rising sea level. And so the provincial government has actually instructed cities to prepare for 1 meter of sea level rise by the year 2100. And as I mentioned, the current diking infrastructure is insufficient to protect our communities. And therefore, hundreds of millions of dollars is going to be required to upgrade the dikes and other infrastructure that protect our communities from the ocean. And so it's not just the idea of building dikes, but perhaps also managed retreat. So for example, the city of Surrey is entertaining the idea of a strategic managed retreat in certain areas where it's actually possibly more cost effective to retreat from the land, surrender it to the ocean, and kind of build a new dike further up in elevation. Because one of the challenges with building a dike higher is that for every 1 meter you build a dike higher, you actually have to build it 8 meters wider on either side. And so when you have dikes, say around Boundary Bay here, and the edge of the dike is right on the edge of the conservation land with this important tidal marsh ecosystem.
Where are you? Sorry.
Oh, sorry. Right here. Yeah. Yeah. If you have these dikes where you're going to be building them wider, you will potentially have to destroy some of these tidal ecosystems to protect your communities. However, and so quite frankly, the status quo option for protecting these communities is just to build the dikes higher. And to further complicate things, the local cities, well, they have a responsibility to protect their communities. And that makes sense. So Richmond, Delta, and Surrey, their responsibility is to protect their communities. However, the tidal ecosystems of the estuary are mostly under provincial jurisdiction. And so this status quo and sea level rise, it really threatens the ecosystems because, quite frankly, the province does not have a plan in place to ensure that these tidal ecosystems of the Fraser Estuary will persist with this increase in sea level. And so, further to that, as I alluded to earlier, tidal marshes and eelgrass, well, that slows down wave energy. And so that actually helps protect our communities from sea level rise. Because if the waves aren't as high, the water's not as high, and your community is not at risk of flooding, or not as at risk. And so with up to 1 meter of sea level rise, if we lose these ecosystems, it actually makes our communities even more vulnerable to flooding. And so I would contend that we need innovative solutions to both protect our communities and our ecosystems. So to illustrate what I mean by this, again, fancy PowerPoint slides. So the status quo here is to just raise the dike higher. But again, with sea level rise, once you've raised it higher, well, there's nowhere for the marsh to go. And so you have marsh loss not only from sea level rise, but also from the expanded footprint of the dike. But there's the possibility of innovative ideas. And this is where we need some of our brightest minds to start thinking about, okay, so what can we do for these tidal ecosystems to ensure that they stick around when we have sea level rise? So one idea I've heard is called this so-called living dike concept. So I'll just give you the Coles Notes version here. So it starts off, you're building the dike higher, but as you build that dike higher, you actually slowly deposit thin layers of sediment every year for, say, a decade or two. So that would allow the ecosystem to slowly catch up. So all of those plants can still catch up with, say, 10 centimeters of sediment every year. Then you add another 10 centimeters, and the plants can catch up. And you keep going like that until it almost looks like you build the toe of the dike out further, but the theory goes, you're still allowing a place for the marsh to persist. And so then with sea level rise, you then potentially still have a lot of those tidal ecosystems persisting. They perhaps remain resilient. Now this idea, there's still a lot of questions that need to happen. Definitely before any such idea is implemented, there's a lot of research that needs to go on. So we need to better understand how these ecosystems may be able to be resilient on their own, perhaps how different rates of sedimentation may be augmented, may be improved to increase the resilience of these tidal ecosystems on their own. But then I really suspect we're going to need some really big ideas, potentially like this living dike concept, to ensure that we still have some of these ecosystems by the year 2100. So I just wanted to kind of summarize this presentation with 3 takeaway messages here. So first off, the Fraser Estuary. It truly is unique. It is important. It is also degraded and at risk of continued loss. Sea level rise. This poses an unprecedented threat not only to our community, to the economy, but also to the ecosystems of the estuary. And not only are these ecosystems of disproportionate ecological importance, but also these ecosystems, they are infrastructure. They do protect our communities, and we can use these ecosystems to continue helping to protect our communities from sea level rise. But quite frankly, that requires public support and advocacy. So my call to action to you is to reach out to your politicians, federal, provincial, municipal, emphasize the importance to them of incorporating these tidal ecosystems into our sea level rise planning. Because again, the way that things are currently done, the provincial government has instructed the municipalities to prepare for sea level rise, but the municipalities don't necessarily have to consider those tidal ecosystems because they're not part of their jurisdiction. But what I would contend is that you can make both resilient. You can protect your communities and protect the ecosystems. And when you do that and you help to increase the resilience of those ecosystems, that helps in turn to protect our communities. So kind of that concept of ecosystems are infrastructure. And so with that, just a few organizations I would like to thank. For the Sturgeon Bank Marsh Recession Project, generous funding was provided by the Port of Vancouver, the National Wetland Conservation Fund, and the Habitat Conservation Trust Foundation. The project was led by the BC Ministry of Forests, Lands, Natural Resource Operations and Rural Development and the Federal Department of Environment and Climate Change Canada, with help from the BCIT Rivers Institute and the British Columbia Conservation Foundation. Big thank you to the Vancouver Aquarium for hosting us this evening. And also thank you to the partners of the South Coast Conservation and Land Management Program. And so with that, does anybody have any questions? Go for it.
Yeah, so thank you, Eric, for such a fantastic talk. That was really, really interesting. And
cool.
I have a microphone here for questions. So.
Is there any estimation for the how climate change will affect the flow of the Fraser River in the future?
So I've seen, so that's a question for hydrogeomorphologists, to throw out a wonderful jargon term there. it's not 100% certain what will happen. As with anything related to climate change, there's a degree of uncertainty. One projection that I've heard is that it's actually thought, so you remember on, hey, I've got the slides right in front of me. Sorry. There we go. On this Fraser River hydrograph here, so that black line was the flow of the Fraser for 1 year, 2013. So long story short, one projection I've heard is that freshet, the peak would be a bit lower, but it would start a bit earlier. So potentially you would have slightly less snowpack and more precipitation possibly falling as rain. And so from what, again, I am not that hydrogeomorphologist, but that's kind of what I understood is potentially lower freshet, but earlier, which also could have repercussions on the ecosystems of the estuary, because the timing here of freshet is at a very important time for marsh plants, when they are kind of at their peak growth. And so when you have that delivery of fresh water, realize that that's the Fraser River. It makes these intertidal ecosystems along the delta front, they're no longer brackish, they're nearly purely freshwater. So 0 parts per thousand, while ocean water at this latitude is about 32 parts per thousand. And also to emphasize just how much water comes from the Fraser. You saw that Fraser River plume. I actually didn't highlight it in my presentation, although I had several images of it. So right here, you see that plume of sediment and fresh water coming out here into the Strait of Georgia. And so that plume is actually how a number of species of freshwater fish from the Fraser watershed colonized areas of the Gulf Islands and Vancouver Island. And so it's a lot of water and sediments. And so small changes in that hydrograph could potentially have big repercussions on the ecosystem. But again, this whole interconnectedness of it, it's difficult to tell. Yeah. You'll get the microphone right there. If you could pass it along, please.
Yes, I wondered if all this dredging that you're talking about that's done every year, would that material be suitable for the intertidal area to build it up like you were describing just a few minutes ago?
Yes. So for that living dike concept, the thought is where you get all that sediment, exactly, is from the dredgeate, the dredge spoils from the Fraser River. And so right now, some of the dredgeate is sold commercially, but a lot of it is actually just taken out into the Strait of Georgia and dumped. And so there is an opportunity to use that sediment, keep it in place, and to, I guess, anthropogenically expand the delta, as it were, perhaps. But definitely, that's what a lot of folks are thinking about.
Here, I do one behind you.
Thank you very much. It was an amazing presentation. You might not have this information, but I was wondering if there's any research done on the impacts of agriculture on the marshes? Thank you.
Any research on agriculture, the effects of agriculture on these tidal marshes? I'm sure there's a lot of research done. I do not recall exactly what it says, but just looking at the whole Fraser Valley there, that's a lot of agricultural land. So you can think of the nutrients from fertilizers, from livestock, that may contribute to algal blooms. So there is actually, see, I even prepared some extra slides for questions like this. There we go. Aha. So on the Lulu Island foreshore, there's actually this bloom for the last few years every summer of ulva. It's sea lettuce, and it's a lot. So here I'm a tall guy, and I've stepped in mats of this ulva up to maybe 50 or 60 centimeters thick. And so it's possible that we would call it eutrophication, so an excess of nutrients may have contributed to algal blooms such as this. I don't know for certain if agriculture has contributed to this particular algal bloom, but that's kind of one of the thoughts. Also, for these tidal marshes, so this is actually at the Lulu Island Foreshore Marsh in Richmond. The pumping stations are there. And so all of the dikes for the western part of Richmond, well, the water in the ditches needs to go somewhere. And the kind of really counterintuitive thing is that if you're standing on top of the dike there, the land where the houses are is lower than the land where the marsh is. And that's because of that disconnection of the Fraser River from its floodplain. So you can no longer add more sediments from the Fraser River, and through agriculture, we've been kind of slowly losing sediments there. Or so is my understanding. I'm not an expert on that. And so there are pumping stations that actually have to pump out the water from the ditches up in elevation into the tidal marshes and out. And so because those ditches are connected to agriculture, there could be nutrient spikes from that. You may also have other substances, perhaps pollutants. I also strongly suspect that certain invasive species and exotic species have been introduced to the marsh via that. The invasive species of cattail is perhaps one of them. And there's also some other exotic grasses that we find up in the high marsh. And hopefully that grad student who's doing veg surveys will be looking at that so we can better understand perhaps how that marsh community has changed, perhaps in relation to those pumping stations. So I know that didn't exactly answer your question, but hopefully it was sufficient. Yeah.
Great.
Hi. Yeah, I've got a question just related to the illustrations you did on the dike. I just wanted to clarify. You had said that if they were to increase the height of the dike, it would be 1 meter high, but it would have to be 8 meters. Was it 8 feet or 8 meters wide? And could you explain why?
So for increasing the height of the dike, what the provincial government, based on different models for sea level rise, has said is we want you to protect your communities under the anticipation that seas will rise 1 meter in height. And so that will require the dikes to be raised different heights in different locations, because some dikes are at provincial standard, some dikes are not at provincial standard. Regardless, there are no dikes that are high enough for this 1 meter of sea level rise. So some dikes may need to be raised 1 meter higher, some dikes may need to be raised 2 meters higher to reach the height required to protect the community for 1 meter of sea level rise. But from an engineering perspective, with the dike structure itself, in order to maintain its stability, from what I understand, admitting that I'm not an engineer, what I've been told is that for every 1 meter you increase the height of a dike, in order to maintain its structural integrity, you then need to widen it. And in fact, the ratio then is for 1 meter in height that you increase it, you need to increase the width on one side another 8 meters. So 1 meter increase in height means you widen the footprint of the dike 16 meters.
He's just adding a comment. So, wow. Okay. And so how did they come up with the magical number of 8 meters? Why couldn't it have been 5 meters, 3 meters, 15 meters? You know, really. And I guess this is my part 2 question to that is, if they were looking at 1 meter of a sea level rise, I would guess you would want to build a 2 meter high dike above the 1 meter so that water's not going to just overflow if it was only built to the 1 meter increase.
Yeah, so as for the rationale for the 8 meters and all that, again, non-engineer, so I'm not going to wade into those specs. But for the dikes, so right now, the dikes are effectively keeping out the oceans, more or less. That's an overly simplistic view of it. And so, again, some of the dikes are have been maintained better, perhaps, than others. And so they don't need to be increased in height as much. And also, not all dikes were constructed at the same elevation. Different jurisdictions or different contexts may have constructed them to different heights. There's also challenges with things like infrastructure such as railroads. So here, I'll show an interesting example of that, actually. Oh, that's not what I wanted. We're getting there. Okie dokie. So there's this point here, right between Delta and Surrey. This is their border. And there's the BNSF Railway, Burlington Northern Santa Fe Railway. See, I remember the acronym. There we go. So this railway goes along here, it goes here, crosses on a bridge here, then crosses in front of Crescent Beach here, and then along the edge there. And so this is a bit of a challenge for protecting our communities for sea level rise, because we want the railway to maintain operation, but we need to build the dikes higher, and the railway goes through the dikes. So to what extent is it useful to build the dike higher if you're keeping the railway at the same height? You'll kind of still have a low point there. So that's a unique challenge, and it's also one of those multi-jurisdictional challenges because the railway is privately owned, while, say, the city of Surrey needs to raise the rest of the dikes. So how do you make that work? You could talk with the city of Surrey. They're better ones to answer that question.
Thank you.
Yeah.
So I think we have time for just one more question. I'll see if I can run up here.
Thank you. So you mentioned that the construction of these dikes is preventing the deposition of sediment in like Richmond, Surrey, Delta, etc. Does that mean that a bunch more is just drifting kind of uselessly to the bottom of the ocean? And if so, what impact is it having on marine life?
So yes, it's any sediment that is not because the Fraser, like we discussed, it can't overflow its banks. So it's almost like you've created this garden hose. While before it was maybe a trail or a wider path that the water could flow, and then you have the sediments accreting, just kind of filtering out. But with the garden hose, it's just pumped out straight into the ocean and goes into the Strait of Georgia. Now, as for effects on marine life, that's really tricky. Again, I think that touches on one of those shifting baselines things where we're not so familiar with the bottom of the ocean in certain areas. But that being said, again, looking at what the Fraser River does and that massive plume, that massive amount of fresh water, there's sediment that is transported from the Fraser River all throughout the Strait of Georgia. I mean, when you're going on the ferry, you can, you'll see the plume north of Vancouver. You'll cross that murky to then dark, deep blue marine water. And so also the Fraser River, before, when it was that windsock, it was just depositing sediment all across the delta. So that is part of a natural process of sediment deposition. And so most likely that allows certain organisms to persist and certain organisms to not persist. As for the garden hose effect and how that affects the marine community, I don't know. Sorry. Yeah. I know that was probably our last question, but I'm happy to stick around for a few minutes if you have any other questions.
And just on the question of the dike, I actually think I know the answer. I've been thinking about it. Is you have to put more water against the dike. As water gets deeper, the pressure increases, but increases, I think it's a squared function. So that's why it has to be so much wider as the compared to the small increase in height. I think that's the answer.
Sounds plausible.
Okay, well, thanks everybody so much for coming. Thank you so much, Eric, for such a fantastically interesting talk. And don't forget that if you do have